Now here the question is, in a parallelogram ABCD with angle A equals 60, the bisector of angle B is drawn, which cuts the side CD at point E. The circle S1 of radius R is inscribed in the triangle ECB, and another circle S2 is inscribed in trapezoid ABED. So here we have this parallelogram. ABCD with this angle A60. If angle is 60, then this angle it is 120. So bisector of angle B will intersect this side CD at E, and this angle it is 60, and this angle will also be 60. That's it. A circle S1 is inscribed in ECB. So we have this circle S1 inscribed here, and we have another circle S2 which is inscribed in this trapezoid ABED. Now it is given that radius of circle S1 is R. So for S1 radius is R, and for S2 suppose it is R1. Now first question is, we have to find value of radius of S1. Now clearly this angle is 60, that means this angle is also 60. So this triangle BEC is an equilateral triangle. So if it is an equilateral triangle, and if we join this point here, this is 90, this is suppose its center C1, then this value it is R, and this is suppose P. Now we know that PC1 upon BP it is 1:3. Now PC1 is R, so from here we get value of BP as 3R, and BP is equal to diameter of this second circle. So from here we get 2R1 equals 3R, or R1 equals 3R by 2. That means this A it matches with S. So this A it matches with S. Now this B is value of distance between centers of S1 and S2. So we have to find distance between centers of S1 and S2. Now we'll drop this perpendicular here. This is C2, and we have to find this length. Now this length here is 3R. This is R. So this length here will be 2R, and this is 3R by 2. So 2R minus 3R by 2 is R by 2. So this distance it is R by 2, and say this point is Q. So value of C1Q is R by 2. Now we have to find the value of C2Q and let this point be R. So what we'll do is, we'll join this center with B. Now this angle is 60, so this angle will be 30 degrees. Then we can write 1030, it is 3R by 2 into BR, or BR it will be 3√3 R by 2. Now BR is same as C2Q. So from here we can write C1 C2 square, it is equal to C2Q square plus C1 Q square. Now C2Q square is same as BR square, so there will be 27 R square by 4 and plus C1Q square, and there will be R square by 4. So this is 28 by 4, 7. So it will be 7 R square. So C1 C2 it is under root 7r. So distance between their centers, it is root 7r. That means this D, it matches with r. Now C is length of common tangent of S1 and S2. Now they'll have a direct common tangent as well as a transverse common tangent. So for the C part, we'll calculate length of direct common tangent, and it is given by under root of D square minus R1 minus R2 square, and length of transverse common tangent, that is under root of D square minus R1 plus R2 whole square. Now this D is distance between centers, and that is under root 7r. So here we write this as under root of, and this is 7r square minus, now R1 minus R2 is, now R1 is 3r by 2 and R2 here is r. So if we subtract them, it will be r by 2. So there will be r square by 4. Now this is 28. 28 minus 1, 27, and 27 is 3 root 3 r by 2, and length of transverse common tangent will be under root 7r square minus, now this is r1 plus r2, there will be 5r by 2 whole square, so 25 r square by 4, now this is 28, so it will be this root 3 r by 2. So in this case, they have asked for length of tangent, and the option which matches this option Q. So this C, it matches with Q. And then option D is find the value of length CE. Now C is effectively length of this equilateral triangle. So suppose this length is L, then we know that L cos 30 is equal to 3R. So we get L cos 30 equals 3R, and cos 30 is root 3 by 2. So it will be this L root 3 by 2 equals 3R. Then this L is 2 root 3R. So value of C is 2 root 3R. That means this D, it matches with B. And that is the answer to this question.